Hello everyone and welcome back. In last videos we have already discussed the consistency for non-homogeneous equation. Fine. In this video we will discuss on homogeneous equations. We have already discussed the working procedure of homogeneous equations. Homogeneous equations are those in which right hand side constants of these equations are 0, and by this we have discussed that homogeneous equations are always consistent. That means they have the solution, and solution are of two types. First is trivial solution, other one is non-trivial solution. Trivial solution is when n minus r is equal to 0. Non-trivial solution is when n minus r is greater than 0. Fine. So let's discuss an example on this. Suppose we have these equations. So we'll find the matrix A here. No need to find augmented matrix as homogeneous equations are always consistent. So 2, 3, minus 1, minus 1. Here we have 4 unknowns, that is W, X, Y and Z. Fine. Other row is 4, minus 6, minus 2, 2. Minus 6, 12, 3, minus 4. Fine. So on reducing it in echelon form, apply the operation R2 minus 2R1, that is it will become 0 here, and R3 plus 6R1, 3R1. So 3 into 2, 6, and it will be added to this minus 6, that will become 0. So 2 into 3 minus 6, this will become minus 12. This will be 0. This will become 4. And by this operation, 3 into 3, 9, 12 minus 9 is 3. This will be not 3. This will be 9 and 12, that is 21. We are adding this. This will be 0 and this will become minus 7. Fine. Okay. Next will be R1 divided by 2, this will become 3 by 2 minus 1 by 2 minus 1 by 2. And R2 divided by minus 12, R3 divided by 21. So this will be 1, 1, 0, 0. This will be minus 1 by 3, this is minus 1 by 3. As you can see, second and third row are identical. So we will apply operation R3 tends to R3 minus R2. This will become last row as 0 row. Fine. And which is in echelon form. As you can see, rank of A is equal to 2 as A has 2 non-zero rows. Let this is R, say, and we know n is 4 here, number of unknowns, W, X, Y and Z. So n minus r will be 4 minus 2, that is 2, which is greater than 0. Therefore equations have non-trivial solution. Fine. And arbitrary values are given to two unknowns, as we have n minus r is equal to 2. Now, matrix equation is Ax is equal to B and B is 0. So A is that we have found here 1 3 by 2 minus 1 by 2 minus 1 by 2. Zero, 1, 0, minus 1 by 3, 0, 0, 0 and 0. Capital X is W, X, Y, Z and capital B is 0, 0, 0. Fine. On multiplying these rows into this column, we'll get W plus 3 by 2x minus 1 by 2y minus 1 by 2z equals to 0. X minus 1 by 3z equals to 0. Fine. So let z equals to k1 and y equals to k2. We can suppose any variable as arbitrary constant. Why we have taken two arbitrary constant here? Because we got n minus r is equal to 2. Fine. So on putting this z in this equation, we get x is equal to k1 by 3, and putting these x, y, z in equation number 1, we'll get w plus k1 upon 2, that 3 will be cancelled out, minus k2 upon 2 and minus k1 upon 2. Fine. This k1 by 2 cancel out and we'll get w is equal to k2 upon 2, where k1 and k2 are arbitrary constants. As k1 k2 changes, the values of w, x, y and z also changes, and by this we will find the non-trivial solution. Fine. I hope this clear everyone. Now we'll find another question here. Find for what values of lambda and mu the given system of equations are these: will have no solution, will have unique solution, and will have infinite number of solutions. So we need to find the values of lambda and mu, and we'll check on for what values of lambda and mu the given system has no solution, unique solution and infinite number of solutions. So A is equal to 1 1 1 1 2 3 1 2 lambda. Fine. Capital X is x, y, z, and capital B is 6 10 mu. We already know the procedure how to find this. First we will find augmented matrix here. What is augmented matrix? Combination of A and B. So AB will be 1 1 1 1 2 3 1 2 lambda, and this is B 6 10 and mu. Fine. So on reducing this in echelon form, we'll apply the operations R2 minus R1 and R3 minus R1. Simply we will subtract first row from row 2 and 3. We will get 1, 0, 1, 2, 4. 0, 1, lambda minus 1 and mu minus 6. Again, this first row remains as it is. Second row will be as it is. We need to make 0 here. For this we will apply the operation R3 minus R2. This will become 0. This is lambda minus 3 and this will be mu minus 10. And this is the simplest form we obtain. And we can see here now it depends on lambda and mu for the consistency and inconsistency. Now the following cases arise here. Case first. In question, first condition is of no solution. What will the condition of no solution here? We know that the rank of augmented matrix and rank of A should not be equal. That is the only condition. The equation will be consistent and the equation will have no solution. So for no solution, equation should be inconsistent. When the equation will be inconsistent? When the rank of A and rank of AB will be unequal. So from this matrix we have already seen here, rank of both the matrix, rank of A and rank of augmented matrix is fixed 2, at least 2. So to make their rank unequal, we need to have lambda is equal to 3 and mu not equal to 10. In that case, rank of A, B will be 3. As we can see here, if mu is not equal to 10, then some non-zero value will be present here, and if lambda is equal to 3, then this term will be 0. Fine. So in that case, rank of AB will be 3. And if we delete the last column, then we will find rank of A is equal to 2. And as these ranks are unequal, therefore equations will be inconsistent. That is, this is the case of no solution. Fine. Now another case second, for unique solution. For unique solution, we need to have equations consistent here. And when will be the equations consistent? When this lambda is not equal to 3. Because if lambda is not equal to 3, then some non-zero constant will be present here, and in that case this row will become non-zero row, and in this way we will find the rank of A is equal to rank of both the matrices is equal to 3. So when lambda is equal to 3, in this case rank of A is equal to rank of augmented is equal to 3. Fine. and we already know number of unknowns are fixed, 3. Therefore n minus r will be 3 minus 3, that is 0. This is the case of unique solution. I hope it is clear. And last case is infinite solution case. When will equations have infinite solution? When number of unknowns is greater than the rank of the matrices. As you can see, number of unknowns 3 is fixed here. That means we need to have rank less than 3 here, and for that the last row should be 0, and this will be possible when lambda is equal to 3 and mu is equal to 10. Fine. Therefore rank of A is equal to rank of augmented is equal to 2 is equal to R. Since n is equal to 3, therefore n minus r, that is 3 minus 2, is equal to 1, which is greater than 0, and this is the case of infinite number of solutions. So in this way we can find the consistency and inconsistency of the equations. I hope it is clear to all. Thank you. Thanks a lot.